Hello, my YouTube family. Welcome to my channel Learn with Dr. Renu Bharti. Today, we will be discussing Introduction to Data Analysis in Research. Imagine having the ability to unlock the power of data, to delve deep into the research and exact meaningful insights that derive informed decisions. This is precisely what data analysis enables us to do. Today, we are embarking on a journey to explore the fundamental principles and techniques of data analysis, empowering you to harness the full potential of your research data. So, let's get started. Now, we will discuss the importance of data analysis in research process. Let's take a moment to recognize the indispensable role that data analysis play in research journey. Very foundation upon which informed decisions are made and groundbreaking discoveries are unearthed. Very first thing is informed decision making. First and the foremost, data analysis empowers researchers to make decisions grounded in empirical evidence rather than mere assumptions. Imagine navigating through a sea of information without a compass. Data analysis serves as that compass guiding researchers towards insights that inform their decisions into confidence. Second, identifying the patterns and the trends. Furthermore, data analysis serves as a powerful lens enabling researchers to peer into the depths of their data sets and uncover hidden patterns, trends, and relationships. Third thing, hypothesis testing. Crucially, data analysis is the bedrock of hypothesis testing. It allows researchers to subject their hypothesis to rigorous scrutiny, validating of refuting research questions with empirical evidence. Fourth thing is enhancing the objectivity. Moreover, data analysis serve as a safeguard against the influence of personal biases by adhering to rigorous analytical methodologies. Researchers can enhance objectivity and minimize the distortion caused by subjective viewpoints. It's about letting the data speak for itself, free from the tint of personal predispositions. In a sense, data analysis isn't just about the crunching numbers, it's about illuminating the path forward, empowering researchers to make informed decisions, unravel complex patterns, validate hypotheses, and uphold the integrity of their research endeavors. Now, we will discuss the different types of data that researchers encounter. Understanding these types is crucial as it influences the method we use to collect, analyze, and interpret our data. The first is quantitative data. Our first category, this type of data consists of numerical information that can be measured. Think of it as the hard numbers, the test scores, the financial figures, the population statistics that provide concrete, quantifiable data points. Quantitative data allow us to conduct statistical analysis, identify the trends, and make numerical comparisons. Now comes the qualitative data. This data is non-numerical and focuses on describing the qualities, the characteristics, and the attributes. This could include the observations, interviews, or the responses from the focus group. Qualitative data provides rich, detailed insights into people's thought, behavior, and experiences. It allows us to explore the complex phenomenon in depth and understand the why behind the numbers. Quantitative is numerical form, qualitative is non-numerical form. The mixed data now. A blend of quantitative and qualitative data. This combination offers a more comprehensive understanding of the research topic by combining the strength of both the types. For example, in a study exploring the effectiveness of a teaching method, quantitative data might include the test scores, while the qualitative data could capture the student's perception and the experiences. By integrating both type of data, researchers basically gain a holistic perspective that can triangulate their findings for the greater validity. Let's talk about the descriptive stats, a powerful tool in the researcher's toolkit. Descriptive stats allow us to summarize and make senses of the key characteristics of our data sets. They basically provides a snapshot of our data, shedding light on its central tendencies, variability, and the distribution. Descriptive stats help us paint a picture of our data story. First is the measures of central tendency. One aspect of descriptive stats is measures of central tendency. These measures, such as the mean, median, mode, provide insight into the typical or average value within our data set. Second is the measures of dispersion. We have the measures of dispersion which tells us about the spread or variability of our data. The range, variance, standard deviation are examples of measures of dispersion. Now comes the distribution. Finally, the descriptive stats help us understand the distribution of our data. It is normally distributed, skewed to left or right, or perhaps multimodal. Visual tools like histograms, box plots, frequency distribution allow us to visualize the shape, the patterns within our data, providing valuable insights into its underlying structures. Descriptive stats, descriptive analysis serve as the foundation upon which we build our understanding of the data. By uncovering the key characteristics and patterns in our data set, descriptive stats lay the groundwork for more advanced inferential statistics. This allows us to go beyond describing our data to making inferences and drawing conclusions about the larger population from which our sample was drawn. Now, the inferential statistics, a powerful set of techniques that takes beyond the surface of data description and into the realm of inference and prediction. Inferential statistics allow researchers to draw conclusion about a larger population based on samples. First is hypothesis testing. One fundamental aspect of inferential statistic is hypothesis testing. Researchers basically have the hypothesis about the population that they wish to validate or refute using sample data. Hypothesis testing involves setting up of hypothesis, collecting the sample data, and using statistical tests to determine the likelihood of observing the results under the null hypothesis. If the observed results are unlikely under the null hypothesis, we reject in favor of the alternative hypothesis. This process enables us to draw conclusion about the population based on the sample. Now comes the regression analysis. It is another powerful inferential technique used by the researchers to model relationship between the variables. It allows researchers to explore the impact of one or more independent variables on the dependent variable. By fitting a regression model to the data, researchers can make predictions and uncover patterns that help explain the variability in the outcome variable. Regression analysis enables us to quantify relationships and make prediction about the future observation. Now comes the confidence intervals. Confidence interval provide a range of values within which we are confident that the population parameter lies. They offer a measure of uncertainty around our sample estimate and help us quantify the precision of our estimates. By constructing confidence intervals around sample stats such as means or proportions, researchers can gauge the reliability of our findings and make informed decisions about the population parameters. Inferential statistics allow researchers to go beyond merely describing data to making meaningful inferences and prediction about the larger population. Now, the data visualization techniques. This is basically a powerful tool that transforms complex information into visually appealing formats, making insights more accessible and impactful for audience. First is the visual representation. Think of visual representation as an artist of the data world. They take raw data and turn it into intuitive graphs, charts, and diagrams that speak volume at a glance. Interactive dashboards. This is imagining a dashboard that not just static but dynamic. An interface that allow users to interact with data, uncovering patterns and trends with a simple click or swipe. Interactive dashboards provide a hands-on experience, empowering users to explore data and draw their own conclusions in the real time. The narrative visualizations. Retelling is a captivating fusion of visuals and narratives. It weaves together compelling visualization with the written stories, guiding audience through data insights in a memorable, engaging way. By contacting data points with human experiences, narrative visualization create a powerful emotional impact. Last is infographic design, the superheroes of data communication. These well-designed graphics distill complex data into visually striking, easy to understand illustrations. With a combination of icons, charts, text, infographics communicate key messages effectively and leaving a last impression on the audience. Data visualization techniques are indispensable tools for conveying insights in a clear manner, whether through visual representations, interactive dashboards, narrative visualization, or infographic. These techniques empower us to communicate complex ideas with the simplicity and impact. Hypothesis testing is a fundamental statistical method which is used to make decisions about population parameters based on sampling data. First is formulating the hypothesis. The first step is to clearly define the null and the alternative hypothesis based on the researcher's questions and available data. The null hypothesis, that is H naught, typically states that there is no effect or no difference with one variable to another, while the alternative hypothesis HA proposes the opposite, that it is having an effect or any difference is making by one variable on the another. Second is selecting the test statistics. Next, we choose the appropriate statistical test such as t-test or ANOVA based on the data type or the research design. For example, a t-test is used to compare means between the two groups, while ANOVA is used for comparing means across the multiple groups, one way ANOVA, two way ANOVA, like that. Third is determining the significance level. We then set the significance level, also known as alpha, which represent the acceptable probability of making type 1 error, incorrectly rejecting the null hypothesis when it is true. Commonly used significance level include 5% or 1%, indicating the probability of making such an error. Here, the hypothesis testing basically involves formulating of the clear hypothesis, selecting the appropriate test, and setting a significance level. These three steps are basically done to draw conclusions about population parameters based on the sample data. Now, the regression analysis. If we talk about the predictive modeling of the regression, it is basically a powerful statistical technique which is used to model the relationship between the variables, the dependent variables or one or more independent variables. It allows researchers to make the predictions and gain insights into how variables basically influence each other, how they are having relationships. If the relationship is linear, non-linear, the researchers can choose between the linear regression, which assumes a straight line relationship, or non-linear regression, which capture more complex relationship. So if the relationship is a straight line relationship, it is linear, and if it is more complex, then it is non-linear. The choice depends on the nature of the data and the research questions. Now, evaluating the model fit. Regression models are evaluated based on the measures like R squared, which indicates the proportion of the variance in the dependent variable that can be explained by independent variables, and statistical significance of the model parameters. After that, we interpret the results from the data. The researchers must carefully interpret the regression coefficients to understand the magnitude and the direction of the relationship between the variables. This can provide valuable insights for decision making and the theory development and moving forward with the research. Now, ethical consideration in data analysis. First and the foremost is informed consent. Researchers should ensure the participants have given informed consent for the use of their data in the research analysis. Second is the privacy and confidentiality. To protect the privacy of each and every participant by aggregating data to prevent the identification of any participant. Third is the objectivity and the biases. Researchers should strive for objectivity in their data analysis and be mindful of potential biases that could influence the finding of any research data. The transparency and reproducibility. Researchers should provide clear documentation of their data analysis methods to ensure the transparency and enable reproducibility of any research. Moving forward to the conclusion and the future directions for the data analysis. If we conclude, data analysis is critical component of any research process, enabling researchers to uncover the insights, testing the hypotheses, draw the meaningful conclusions and findings. As we look to the future, advancement in the data science and machine learning will undoubtedly continue to shape the way we approach research and extract value from the data. Moving forward, researchers should focus on developing more robust and ethical data analysis techniques, continued Collaboration between the researchers, data scientists, and subject matter experts will be essential to drive innovation and push the boundaries of what is possible through the data-driven research. This is this diagram shows the process of data analysis. The first is the data product. Second is the insight visualization, how we represent our data. Second is the data analysis and the models through regression and the regression analysis. After that, we process and clean our data. Second is next is the raw data collection, and last one is the reality. Main is the findings of our research. With this information, we end our video. If you have any question, write down below in the comment box. Till then, happy learning, and students can suggest what topic you want next for the presentation or your videos or your explanation. Thank you.